Hello everyone, I'm Bernard Jin. I'm on FTC team 17080, NewT.exe, and today we'll be talking about intakes. So, starting off, what is an intake? An intake is the part of your robot that actually allows it to secure or get control of game elements. They are generally very game specific. Each game usually comes with its own unique selection of scoring elements, although sometimes they do reuse it. Sometimes it can be combined with an outtake. This is usually in the cases where you don't have to send the uh, scoring elements very far, or you have a low possession limit. For example, if you only have one thing that you need to take control of, a simple claw that also raises up and deposits can be a suitable intake. And for intake designs, you want to go with the maximum of you touch it, you own it. Because in the FTC rules, uh, ownership or control is defined as if the object's moving is under your influence, the influence of your robot. And if you touch it and it's rolling, that often means that you're controlling it in some way. So for intake designs, you want to make it so that when you touch it, you're able to get full control of the part. For design considerations, you want to consider size, how large is it, as well as uh, how large is it in your robot, as well as compared to the element that you want to take in. Reach, how wide of an area do you have to take in, and how easy it is to take in from the area. For example, if you have a huge sweeping intake, that has huge reach, and it would be fairly easy to control to get something within the area to control it. Versatility, if you're intaking different shapes of elements, for example, balls and blocks, you want your intake to be able to get taken both of them. And finally, speed. If you're trying to take in a lot of elements, you're going to have to take in quick succession, then you're going to want a fast intake. Well, if you're only intaking one, you can generally go a bit slower. Starting off, we have passive intakes, also known as claws. They don't use actively spinning components to control elements. Instead, they have like a state where you don't have an element, for example, for a claw to be open, and a state that you do, for example, for a claw to be closed. They're simple. Uh, they don't include like constantly spinning parts, and generally they don't require a lot of moving parts. They're versatile. With claws in particular, they're able to grab almost any shape of elements. For example, here you can see that it's grabbing the relic on the left as well as the cone on the right. They're lighter and they use fewer actuators, meaning that you don't have to dedicate, for example, your own motor to a passive intake. It can usually be run off the servo or something similar. And this helps you be able to put it on a huge extension if that's part of your robot design, as well as helps preserve actuators for other parts, for example, your outtake or your drivetrain. They also have fewer points of failure, again, fewer moving parts. Unfortunately, because they have to go between open and closed, they are a bit slow, and oftentimes they can't intake more than one element at a time, meaning that this is really most commonly used in games where you have a possession limit of only one for an element. Next, we have tubing. Tubing intakes use very fast spinning tubing in order to collect elements. For example, here you can see on the left. They're often chained together for transferring. Once again, on the left, you can see a series of tubing rollers, and these allow the elements to move from the bottom all the way over to the top of the image. They're very fast at intaking because they're constantly spinning, and they're also fairly versatile. The tubing is flexible, or at least most tubing is. We'll get to that in a bit. And that allows it to bend around elements of different shapes and sizes. In particular, it works well with smaller and odder shaped elements. Unfortunately, they require high RPM, once again, because tubing's floppy most of the time. And because the tubing bends so much, it's harder to take in larger elements. So as for specific types of tubing, you have quite a few materials to choose from. Here I have 4. So starting off, you have silicone tubing, which is very flexible, but unfortunately needs to be run at very high RPM. And it's difficult to take in elements, because it is very flexible, it's difficult to take in elements that don't like to move. For example, in Skystone, the huge stones or huge Lego bricks. Next up, we have harpoon tubing, which is fairly flexible, somewhere between silicone and vinyl tubing. It can be used for larger elements, and personally, this is my favorite tubing to use in tubing intakes. Next up, we have vinyl tubing, which is fairly stiff, and it's also fairly good for, it provides a nice balance of stiffness and grip, which makes it good to our intake. In order to assemble it, you'll want to heat it in order to soften it, because otherwise the stiffness might make it difficult to fit through holes. And because it's stiffer, you'll want to run this at lower RPM, meaning that if you're dealing with a ton of smaller elements, vinyl tubing might have a slower time in taking it than, for example, silicone tubing. And finally, we have Teflon tubing, which is very, very stiff. If you guys have used 3D printers before, it's made out of Bowden tubing, basically. It's not very good for intakes because A, it's stiff, and B, Teflon is very slippery. And because it is stiff, you need to run it at very low RPMs. Next up, we have rubber band intakes, which uses rubber band rollers to take in elements. As you can see over here, we have 2 plates with rubber bands stretched on between them. And what this does is, because there's nothing supporting the rubber bands in the middle, the rubber bands can bend around elements. This works particularly well with rounder elements, as it can sort of just like roll the elements up. It can be powered with servos. These don't need to run at extremely high speeds, so lower speed, the lower speed that a servo can provide might be able to work. Because they use rubber bands, they're fairly fragile, and they'll need to be replaced fairly quickly, both because rubber bands themselves are fragile, and you'll have them in constant tension the entire time, so they'll start to loosen as you keep running them. And finally, because there are a bunch of holes in between the rubber bands, and because of how flexible the rubber bands are, it'll be difficult to take in elements with sharper corners, as well as elements that don't like to move a lot. Next up, we have 3D printed intakes. 3D printed uses flexible 3D printed parts, for example, parts printed in TPU, in order to take in elements. They are very versatile and can be fine-tuned to exactly your liking. Again, because you 3D print them, you have basically full design control over them. So you can make it whatever shape, whatever stiffness you want. Again, they're very versatile. Because most flexible filament is still fairly stiff, unless you get something crazy like Ninja Flex. They can be servo driven, although if you plan to take in a lot of elements at a time, you might still want to go with a motor. Unfortunately, because they use flexible filaments, they can be difficult to print, especially on Bowden printers. So for these, you'll often have to print slow in order to make sure that you're not losing out on quality and durability, or use a direct drive printer. And finally, we have wheel-based intakes. Wheel-based intakes uses wheels to roll in elements. Because they use wheels with flat sides, and because they use circular wheels, they work well with elements with flat sides. For example, the stone over here has 2 very long flat sides, and the rings used in Ultimate Goal, I don't have a picture here, but they had a single very flat side on the top, which many teams use wheel intakes in order to take in. Compliant wheels in particular can bend around elements, increasing grip. Unfortunately, wheel-based intakes are usually fairly large. As you can see down here, this intake takes up pretty sizable portion of the robot. And because wheels themselves don't have much compliance, even compliance wheels only have around like 1/2 inch to 1 inch of give. They're fairly specialized for elements that you want to take in. All right, so finally, some tips while designing intakes. First of all, beware of the control limit. Generally, you want to design intakes to match, to only be able to fit the amount of elements that you can control at a time. For example, if you can only control one element, you should try and design your intake to only be able to intake one element at a time. Next, if you have a lot of different elements, for example, with relic recovery, you had huge foam cubes, but also that weird, that odd-shaped Lego man, not Lego man, the odd-shaped relic, which is this shape over here. You might want to include different subsystems for relic recovery specifically. For relic recovery specifically, most robots had a cube to intaking element as well as a relic intaking subsystem. You might also want to consider using an extendo intake, where you put your intake on a huge set of slides, or some other way to extend horizontally. And this is useful, particularly in games where the main goal is cycling, because then you minimize drivetrain movement and move like the fairly imprecise movement of the drivetrain into a very precise linear movement in another subsystem. But for this, you'll want to watch out for balance, in particular, if you're sticking something out really far. And finally, consider how the elements are going to be positioned. For example, if the elements roll, or if they're packed up together, or if they're up against the wall, you want to be able to design your robot to your intake to be able to intake the elements no matter which way they're positioned. So yeah. All right. Thank you all for coming. Thank you all for watching. And we also have a couple other videos on our YouTube channel discussing other subsystems. So yeah.